In this video, we're going to translate some sentences which require multiple quantifiers. We'll be using this symbolization key. Let the universe of discourse be people, let LXY mean X lies to Y, and let little g be grima. Suppose we want to translate this sentence. Grima lies to everyone. Since our universe of discourse doesn't include anything besides people, we can use a universal quantifier to mean everyone. So we translate the sentence as, for all x, LGX. The variable only gets its meaning from the quantifier, so we could use any variable we want. It would be equivalent to say, for all y, LGY, or for all z, LGZ. Now consider this sentence. There is someone who lies to everyone. We start with an existential quantifier, exists x. What is there that exists? An x that lies to everyone. X lies to everyone is structurally like grima lies to everyone, and we can translate it using a similar formula. So what we end up with is exists x for all y, LXY. Now consider this sentence. Every person is lied to. This says that everyone has a feature, so we start with a universal quantifier. For all x, x is lied to. We don't have a predicate for x is lied to. So we can paraphrase what we have, though, to make explicit how we're going to say it. X is lied to means someone lies to x. Someone lying to x is going to need a quantifier. And it can't be a quantifier for x. We can't say exists x because we've already got a for all x out front. So we say for all x there exists y, where y lies to x. And that just, to complete the translation, becomes for all x there exists y, LYX. Now consider the sentence, everyone either lies or is lied to. At a big picture level, it's a universal sentence. For all x, x either lies or is lied to. And we can recognize that x either lies or is lied to as a disjunction. So in the next step, we split it up. For all x, parentheses, x lies or x is lied to, close parentheses. And again, x lies can be paraphrased as x lies to someone. X is lied to as someone lies to x. That makes explicit that we're going to need more quantifiers. We're going to have to say someone is being lied to or lies. Taking the final step, we get for all x, parentheses, exists y, LXY, or exists y, LYX, close parentheses. Consider this sentence then. Grima is a liar. We don't have an extra predicate for being a liar, and we don't necessarily want to add one, because that would remove any logical connection between lying, the predicate x lies to y, and being a liar. What we can capture with our symbolization key is Grima is a liar in the sense that Grima lies to someone. And that we can translate as exists x, LGX. Now consider this sentence. Every liar is lied to. This is a sentence of the form, all of these are those. It says that everything with one property has another property. We can translate it with a universal quantifier and a conditional. For all x, if x is a liar, then x is lied to. Now we can paraphrase those to bring them closer to something we can translate. For all x, if x lies to someone, then someone lies to x. Finally, the someone can be handled with an existential quantifier. So we get for all x, parentheses, exists y, LXY, arrow, exists y, ly, x. Now consider this awkward sentence. Everyone who is either a liar or who is lied to is a person who lies to or is lied to by Grima. Notice that this is another all of these are those sentence. It's everyone who has one feature is a person who has another feature. So we translate it using a universal quantifier. For all x is either a liar or is lied to. Then x lies to or is lied to by Grima. Now we look at each side of the conditional. Each one is a this or that, and we can translate those as disjunctions. Translating each of those, we finally get for all x, parentheses, exists y, lxy, or exists y, lyx, close parenthesis, arrow, parentheses, lxg or lgx, close parentheses, close parentheses. To be honest, I've been doing this a long time, and I couldn't just look at the English sentence and start writing the final translation front to back. What I'd be doing, if not on paper, at least in my head, is what I've done here on the screen. I'd be going through it step by step and breaking it down. Each step along the way is a simpler translation problem. The first step recognizes the pattern, all of these are those. The second step recognizes disjunctions. And the final step, on the antecedent side, recognizes that we need an existential quantifier, and on the consequent side, notes that Grima is a constant, and we can just plug it in. So along the way, it's a bunch of smaller problems, and the key to doing a complicated problem like this one is to be able to break it up and recognize where the smaller problems are, and not get ahead of yourself and try to do it all at once. So here's some general advice for translating from English into QL. First, recognize the structure of the English sentence. Think about what the main logical operator will be. Is it one of the standard patterns for connecting two properties, like a all these are those sentence? Second, paraphrase, replacing complex phrases with things that can be translated more easily. Third, write pseudo-English in between steps along the way. I say pseudo-English because it'll still contain English words, but it'll also contain parts of QL, like variables or connectives. The in-between steps are the things I've highlighted in blue in this video and in previous videos. If you keep these strategies in mind, even larger, more complicated translation problems that might require several quantifiers, break down into lots of separate, smaller problems that you can approach step by step.